Good morning. Myself Siddhama Prakash Reddy. Today I am going to discuss about conversion of the galvanometer into ammeter. So for this we connect shunt resistance in parallel with galvanometer. Why we are adding shunt resistance and the two in parallel? Why not in series? So let's get started our discussion. Let's say I have a circuit of with resistance 2 ohm and you can voltage of battery 2 volt. Now I want to measure the current in the circuit. So let's say it is I. So I will be from we have found that V is equal to IR, that is Ohm's law. So here voltage is 2 volt and resistance is 2 ohm. So that is 2 which get cancelled and we will get 1 ampere. Now again I want to measure this current using galvanometer. So let's redraw the circuit with addition of a galvanometer. Okay, and rest everything is same. So this is 2 ohm and this is 2 volt. Let's say galvanometer having a resistance of 1 ohm. So now again I want to measure the current. So will the current will be same as before? No, because the resistance is getting changed and current will also get changed. So let's say it is I1. So now let's measure I1. Let's say I1 is equal to total voltage, it is 2 volts, and total resistance, as these two are in series, so total resistance will be 2 plus 1 is equal to 3 ohm. So that is 2 volt by 3 ohm, which is equals to 0.66 ampere. Okay, so now whatever the reading I am getting through galvanometer is 0.66 ampere, but the initial current is 1 ampere. So while applying the galvanometer, we should not change the current in the circuit. We should able to measure the current which was flowing in before, same as amount. But here by applying galvanometer, they are changing the resistance, so which in turn changing the current. So here we are getting a wrong reading. This is not accurate. Okay, so now to make this galvanometer more accurate, like we should not change the initial current amount. So what we will do, let's add a resistance to the galvanometer in such a way that is parallel. Let's redraw the circuit. Okay, so this is 2 ohm and this is 2 volt. We have taken galvanometer as 1 ohm. So now we have to add very small resistance in parallel to galvanometer. Let's see what will happen. Let's say I have 0.1 ohm in parallel to galvanometer. So what will be the total resistance for this one? So as these two are in parallel, it is galvanometer and shunt resistance. These two are in parallel. This is 1 ohm and this is 0.1 ohm. So result R equivalent will be what? 1 into 0.1, as they are in parallel. So 1 plus 0.1, that will be 0.1 divided by 1.1, which is approximately equal to 0.1 ohm. Okay, so now the current, so now the total, this is coming out to be approximately 0.1 ohm, and here it is in series with this resistance. So R equivalent, total R equivalent will be not 2 plus 0.1 ohm, that is 2.1 ohm. Now let's calculate the current in this circuit. Let's say it is I2. So now I2 will be I2 will be, total voltage is 2 volt. Voltage is same in all cases, and total R equivalent is, which is 2.1 ohm. So that is 2.1 ohm, which is 2 by 2.1. This is approximately equal to same 1 ohm, 1 ampere. So it's closed. So what advantage we are getting here by applying a shunt resistance? Shunt resistance means very small resistance. So by applying very small resistance in parallel to galvanometer, the R equivalent will be very less. So when we add very less resistance in series with this one, so it won't affect much, because total resistance is getting changed, but not that much amount as compared to before. So we know this one, right? When in parallel, the R equivalent, let's say this is R1, this is R2, the total R equivalent will be less than the least resistance, that is, here it is galvanometer, that is 1 ohm, and here shunt resistance, that is 0.1 ohm. So the R equivalent will be what? Less than the least. What is the least one? 1 or 0.1? Shunt resistance, obvious. So R equivalent will be less than 0.1. As shunt resistance is very less, so total R equivalent is becoming very less. So through this, current is getting not changing, but very little amount. So this is the one advantage we are getting through by applying a shunt resistance in parallel to a galvanometer. So that's why we are adding a shunt resistance in parallel to galvanometer. Why we are not adding in series? Because if we add in series, this is galvanometer, let's say, and if you add series, it will get added, because R1 and R2 as in series, the total resistance will be added, but in parallel it will get reduced less than to the shunt resistance. So to get that advantage, we are adding a shunt resistance in parallel to galvanometer. I hope you guys understood. Thank you.